Hi, kids, and welcome back to another enrichment activity. Okay, today what you're going to do, the last enrichment activity, you created a compass for making circles, okay? And you learned that the diameter of a circle is the distance across through the center. A radius is half the distance of the diameter, and when you establish a radius, you actually create the full circle, and that the circumference is the distance around the circle. Well, circles are a really big thing when it comes to a whole lot of manufacturing and a whole lot of things that we use in our day-to-day lives. So at some point, we have to learn how to make circles reliably, and we need to learn how to deal with circles reliably. So that brings me to this little device that you're going to be making, okay? Now, this device is actually a paper plate maker. Well, it's sort of a paper plate maker. It's not motorized, so you have to do it the old-fashioned way and hand crank it, okay? Which means that you're going to have to really get used to using it. You might even need some help from somebody. But, it's a paper plate maker. Okay? And so what it's going to do is we're going to show you how, or hopefully you're going to figure out how gears and gear ratios help transfer power and energy, but they also can be used to create things. All right? So, and that's part of the reach here, is to help you see that, the concepts of geometry and the concepts of gears don't just apply to simple gear trains. Okay, so anyways, the first thing you're going to do is you're going to take a axle, a black axle, and you're going to put a pillar on it. Then you're going to take another black axle, and it's really, really important when you take this one, you place it in there, okay, so that the split is facing up, but then the octagon peg is facing up there. Then you put a blue pillar on the end like that, and then with the split facing up and the octagon going into the blue pillar, you have it like that, okay? Then we're going to put a blue pillar off the front, and again, you want the split peg facing up so that there's a split peg facing at the bottom. So you have a split peg and a split peg, all right? And that's going to keep it level on the surface of the table or desk. The other side, you put another one on there, and then another 6-way axle, and you put it in there so that all the splits are down. That way, when you put it on the desk, it's nice and level, and it doesn't wobble, because this thing's tricky enough to work. Now we're going to build up the tower for the actual mechanism of making the paper plate. Okay, so you're going to put another pillar like that, and then you're going to put a pillar on there so that facing forward is this little split cylinder right here. So you want it to face into the C, okay? Then you put another pillar on top, and you put another pillar on top of that, making sure that the split cylinder is facing towards the front, because we're going to put gears on those. Now, what we put on top here is a little yellow peg, and that of course is going to have the split going up, okay? So now we are pretty much have the frame done, and what we're going to do is we're going to start with a red gear, and we're going to place it on this second from the bottom axle. So this is what we have, okay? Then you're going to take a yellow gear and snap it in place. Okay, now at this point, these things are going to be fitting nice and snug. They're going to turn. Notice how you have two gears, an even number, and when you rotate it, I hope this is coming out on the video, I'm rotating it clockwise, and the yellow gear is going counterclockwise. So as I rotate this red gear clockwise, the yellow gear goes counterclockwise, and that is a gear train that has an even number of gears, okay? Now this happens to be a 1-to-1 ratio because this gear and this gear both have the same number of teeth. They are the same diameter in terms of their outside dimensions, okay? So now what we're going to do is we're going to take this crown gear and we're going to put it down on top of the peg, okay? And now this is kind of neat because you can see that now we have 3 gears on there. And as I turn the red gear clockwise, or however you're seeing it, the yellow gear turns counterclockwise. Okay? And then the blue gear, if you look at it, which direction is it turning? Okay? So the orientation is changed even more by the right angle put into those gears, okay? So that right angle. So what it means is you can take the energy and you can make it go around 90-degree angles, 45-degree angles by using crown gears. But you have to remember that that's going to influence the way the gears are turning in relation to how you're looking at it. All right, so anyways, now you're going to take a blue pillar and you're going to put it right down into the crown gear like so, right down into the crown gear. Then you take a black axle and you're going to put it in there so that you have the octagon goes down in, and then you have an octagon going off to the side. And then you'll put the octagon peg on, and so this is what you have. Okay, so now we're making the handle of our paper plate maker. So to finish off the handle, we're going to take this yellow peg and we want the split to go up. So we have the split up, and now we could actually start cranking it like this. But to make it easier to crank, we're going to put a gear on there. And so now you can see what we have. Now notice it's going to jam a little bit, and you kind of have to let this machine kind of work it itself out, get it adjusted a little bit, and then you can crank it. Okay, and you'll get a feel for how it cranks and how it works best and how it doesn't. You'll probably have to feel with your fingers the best amount of pressure to put on it, the least amount of pressure. But your goal is to get good enough on it. It won't even turn on me. So that's a part of STEM. Part of STEM is getting things to work. I mean, sometimes we build something like this and it's like, wow, we did everything we were supposed to do correct, and it still won't work. Well, that's why engineers use the engineering design process, where they ask a question, what's the problem? Well, we want to build a paper plate, okay? So let's brainstorm some ideas. Okay, we're going to come up with this idea using gears to feed the paper in, to crinkle the paper around the edges of the paper. And then we're going to plan it up and we're going to build it, okay? And then what most people don't realize is that in the engineering design process, step number 5, 1, 2, 3, 4, 5, is improve your design. And that sometimes involves a whole lot of little teeny tiny adjustments. And that's one of the most frustrating things about being an inventor and being in the STEM field, where you're trying to come up with something that will work all the time, every time. Okay? So anyways, there you have it. There is our paper plate maker. And you'll probably get pretty good at using it. Mine keeps loosening up for some reason. And what we're going to do next, okay, once you've built that, you're then going to draw the circles that I have listed in the instructions. And you'll cut these circles out. And what you'll try to do is feed these circles into these gears and crank those gears so that they put the crinkle into your paper plate. And so I don't know if you can see it or not, but you can see how it started to crinkle it up, and so you can see how you can make a paper plate on the paper. Now, gotta warn you, it's very, very frustrating, and I have students who are here in school trying to make paper plate machines, and it is a difficult thing to get working. But those who get things working are the ones who get to surge ahead in the industry. Okay? All right, good luck with your paper plate maker.